Hi guys, so they're finished, or rather the concept's finished and the prototype's finished, but I've not actually finished the entire project, but it's close enough. It's close enough to show you it being controlled by the Arduino. Now, you can see that they're on here. They look a little bit yellow. I think it's something to do with the white balance on the camera. They certainly look perfectly normal to me. I do have a yellow light shining at me as well at the moment. Now, I'm just going to switch them off and reset the Arduino. So, there we go. So this is what they look like off. I've only made 3. I was going to make a few more, but for now this will do. I just want to show you how they work, how we can interact with them. Now, at the moment I've only implemented RFID and a light-dependent resistor so that it can change with the ambient light in the room. What I was going to do was a clap switch, but it turns out that's quite difficult. So, well, it's not that difficult. I mean, I developed some code for it, but the problem is I had this Electret microphone. Let me just get it. I have this Electret microphone, but I think the potentiometer on it's damaged. So, because it has a built-in amplifier, it's either on fully or off fully, so I think the potentiometer is damaged, so I need to get that fixed. But it means that I can't really monitor much on this. It will detect a clap, but it also detects the slightest vibration, so I can't alter it, so I'm not using that. But as I said, it's got the light-dependent resistor and it's got RFID, so I'm just going to demo those and then we'll have a look at what the circuit looks like. So if I just switch it back on. Now currently its standard state is off, so that's what it'll do until it has some external stimuli. Now there's a physical switch on the breadboard there. It's just a wire going to a pin on the Arduino, and that's cutting off the LDR, the light dependent resistor, so that it doesn't mess around with it. But I'll just show you the RFID. Now this uses one of these little key fob tokens. RFID stuff's really, really cheap. I think I picked up that reader from eBay for about £5, and these tokens were about £1.50, and I should have got 5, but I only received 1, which is why I was a bit hesitant about doing this. But this one won't allow me to differentiate between pictures, but I can just activate them all. So if I just hover that over the reader, it should automatically light. Now the idea behind the RFID was so that you could have a wall of pictures at home, in a family home, and you'd have a picture of each one of the family members there. And when they came home, they'd put their keys in a spot by the door, and their picture would light up because it would have read the RFID tag. And then again, when they left, it would keep reading and looking for that RFID, and when it didn't find it, it would switch that picture off. Now that was the idea, but you could also do this with loads of different applications with these tags. There could be loads of things. So that's it using RFID. Now, let's just put that out of the way. You don't want to have these on all the time, or at least I wouldn't want to have them on all the time, because you don't want to spend the money on the lighting for one. You might want a different kind of light in your room, or when it's bright outside, you don't necessarily need these on. So if I just unplug this physical switch here, you may have noticed them dim slightly. But it's quite bright outside, even though it doesn't seem like it in here, and I've had to put a lamp on, but the LDR is sort of pointing out the window. Now, if I take this lamp and shine it over the circuit here, you'll see these dim. So they dim, and then they go completely off after a certain level. There we go. So that's pretty simple. And I don't think I'm going to do anything else with it. I think that's it. I'd love to be able to do the clap switch. I'm going to try and figure out how to change the potentiometer on this and then have another go. But currently I'm happy with the circuit that I've got. I think I'm not going to use the RFID for this because I live on my own, so there's no point me having some kind of entry system with the RFID. A bit of home automation though, I think would be good with something like this, so I could put my keys down and it would automatically put the kettle on or something like that. Anyway, let's have a look at the circuit a bit closer. Actually, before we do that, I did want to say that you could make these internet enabled pretty easily. If you remember, I don't know if you've watched it, but I made the Internet, which was a Facebook and tweet notifier, and it had a server on it and connected via the Ethernet shield to the web, to a PHP form PHP page that I had, and it would poll that page and look for new information. You could do the same with this and have a Twitter Larry bird there, or a Facebook thumbs up, or perhaps a Google Plus symbol, and have those light up on the wall. I think those would look really cool, just sort of line up on the wall somewhere, your social media wall. So I think that would be quite a good idea. So maybe if anyone wants to have a go at that, then I'll be happy to help or offer advice or anything like that, but I'd love to hear about your projects. Now let's have a look at the circuit a bit more closely. Okay, so this is the circuit. It's a little bit of a mess. We've got the RFID reader here, which has the pins on the wrong side, I think, but I didn't put it together, it came like that. And the antenna here, and this is what the token looks like there. Now we're just using a standard Arduino Uno, but actually this one's a compatible version, so it's a cheaper one from eBay. I know I'm sort of an advocate for buying locally and buying proper brands to support them, but it was only £5 and I needed one cheaply, so I got that. Now you'll see from, in fact, crumbs, I should turn this around. I'm going to unplug it for now, just so I can turn it. Now you'll see here there's a series of transistors. Let's just make sure this is in focus. Just. There's a series of transistors. Now these are the ones that I showed you in the last video, and I've got some resistors here, and it all wires into the Arduino. Now these go to the pulse width modulation pins, the PWM pins on the Arduino, so that I can change the duty cycle of the high-low bit coming out of here, to turn these on and off, to alter the brightness of the screen, of the displays there. And the LDR is connected here. That's really, really simple to wire up. You can just Google it. You just need a resistor between your output pin, and you need to whack in 5 volts. I think I'm only using 3.3 just because it was available, so I'm just using that. Now I'm just going to explain how the transistor connects up to these picture frames. Now we have 12 volts and we have ground. I'm getting 12 volts coming into the Arduino from the adapter, and I'm using the voltage in pin to get that 12 volts out. So the picture frames are connected to 12 volts. So let's put the picture frame here. So they're connected to 12 volts, and their ground is connected to the transistor. So let's just draw one of those. So there's my transistor. Now the center pin here is the one connecting to ground. I can't remember which ones these are called. I think it's collector, emitter, base, but check with your transistor to make sure you're using the correct one. And this one here is connected to ground, and this one here is connected to my PWM pin. Now what I'm doing is I'm changing the duty cycle on and off here so that I can make the connection there. So it just allows current to flow between the pins. So it allows the ground to connect there. That's essentially it. It's a bit more complicated than that. If you want to know more about transistors, you should probably Google that specifically. But the duty cycle for this is essentially a square wave, so it's on, off, or digital 0, 1, like that. So that's the duty cycle, and you can change the speed at which that changes, so you've got a 25%, 50%, 75%, that kind of thing. But you can do it with values of 0 to 255. And I'm just translating using the LDR. When it's running from the LDR, it's just translating the analog signal it receives to this. So I'm just mapping the same data across so that it's got that variance in there. That's pretty much it. There's nothing else really to show you. I've kind of gotten a bit bored of this project now, so I'm probably going to drop it and move on to something else. A robot? Hell yeah. Okay, no, I am making a robot. It's going to be a self-balancing robot, so hopefully that will be interesting and I'll let you guys know about it. Anyway, thank you for watching, and if you have any questions, I'm always happy to answer them, so please feel free. Okay, bye.